In this video we're going to look at how you generate a sequence when you're given an nth term. An nth term is just a piece of algebra that has an n in it. So this expression here, 4n plus 1, that's an example of an nth term. Now, we've been asked to generate, and generate basically means find or work out, the first 5 terms of the sequence. So to do that, you take this nth term here, this bit of algebra, and you change the n, the unknown thing, for whichever term you're looking for. So if you're looking for the first term, you change n for 1. If you're looking for the second term, you change n for 2. If you wanted the 20th term, you change n for 20. So we've been asked to find the first 5, so we're going to change n for 1, change n for 2, n for 3, 4, and then 5. And this process is called substitution. So the first term here we're going to take 4n plus 1, which means 4 times n plus 1, and we're going to substitute the n for a 1. So we want to do 4 lots of n, and n is 1, plus 1. And that will give us 4 times 1, which is 4, plus 1, which is 5. So the first term is 5, and this was when, just to help you remember, n equals 1. For the second term then, we want to do 4n plus 1 again, but n is 2 because we're after the second term. So it's still 4n, 4 times, but we've changed the n for a 2, and it's still plus 1. So it's 4n plus 1. 4 times 2 is 8, plus 1 is 9. So when n equaled 2, the second term, we get 9. And you continue this process on. 4 times 3 plus 1 for the third term gives you 13, which is the third term, and then 4 times 4 plus 1, which gives you 17 for the fourth term, and for the final term you've got 4 times 5 plus 1, which equals 21. So the first 5 terms of this sequence are 5, 9, 13, 17, and 21. Right, let's have a look at a different example, 3n minus 5, and again we've been asked to find the first 5 terms, so you do exactly the same thing, you substitute in the first 5 numbers, 1, 2, 3, 4, 5, so we're going to do 3 times 1, and then take away 5, then 3 times 2 for the second term, take away 5, 3 times 3, take away 5, 3 times 4 for the fourth term, take away 5, 3 times 5, take away 5, and then work these out, and these will give us our first 5 terms. So 3 times 1 is 3, then take away 5, you end up with minus 2. 3 times 2 is 6, take away 5, that's 1. 3 times 3 is 9, take away 5 is 4. 3 times 4 is 12, take away 5 is 7, and 3 times 5, take away 5 is 10. So these are our first 5 terms. The sequence starts with minus 2, then it's 1, 4, 7, and 10. You might notice something interesting about this sequence. It goes up in 3s each time, and in the nth term expression there was a 3 in front of the n. This is always the case if we have a look back at the previous one. This one was 4n plus 1, so as you might expect this sequence goes up in 4s. This is a nice little way to make sure and check you've done your answer correctly, because it should go up in whatever was in front of the n. Okay, here's 3 for you to have a go at. Press pause, have a go at those, and when you want the answers, press play and I'll take you through them. Okay, here are the answers then. For this first sequence, the first number is 10, and then 17, 24, 31, and 38. Now I've not done the working out for these, but you may find it easier to write the working out. If it helps you in an exam, of course, do write the working out, because there'll be marks or credit for it. In this next one, your first term is minus 4, then minus 2, then 0, then 2, and then 4. And for this last question, the sequence goes 1.5, 2.5, 3.5, 4.5, and 5.5. And for this last one, there isn't a number in front of the n. However, there is, it's just a 1. We don't normally write a 1 when we talk about 1n or 1x. So if you didn't get these answers, it might well be because you didn't treat n as 1. So it's just 1 times 1 plus 0.5, 1 times 2 plus 0.5, and so on. Right, let's look at some slightly harder sequences. 10 minus 2n. Now it's exactly the same logic again. You're going to change this n here for the numbers 1, 2, 3, 4, 5. But you need to be careful when you do your working out. So we're going to do 10 minus 2n. So minus 2 times 1 first, because we want to do n equals 1. 10 minus 2 times 2. And then 10 minus 2 times 3. So this here, 1, 2, 3, represents my n at the end that I'm changing. Then 10 minus 2 times 4. And then 10 minus 2 times 5. Now what you need to be really careful of here is BODMAS. Because when you do this 10 minus 2 times 1, you do not do 10 take away 2, which is 8, then times that by 1 to get 8. That's not how it works. What you need to do is the multiplication first. Now in this case, actually works out as fine. You'll get the same answer, 8. But in all of the other ones, that won't work. So you need to do the 2 times 1. Whatever that is, 10 take away the result. So 2 times 1 is 2. And then 10 take away 2 is 8. So that's our first term. The next one, you come across to the multiplication first. 2 times 2 is 4, and then 10 take away 4 is 6. So if you did this one from left to right, you do 10 take away 2, well that's 8. 8 times 2 is 16, which isn't the answer. You have to use BODMAS. So this next one, 2 times 3 is 6. 10 take away 6 is 4. And then 2 times 4 is 8. 10 take away 8 is 2. And then the last one, 2 times 5, well that's 10. 10 take away 10 is nothing. So that's 0. So this sequence comes out as 8, 6, 4, 2, 0. Now once again, you will notice this fits with our rule earlier that in front of this n is a minus 2, and the sequence is going down by 2 each time. If you did it the other way and you didn't do BODMAS correctly, it would go 8, then 16, then 24. Actually, the 8 times table. So it wouldn't go down in 2s at all, it would go up in 8s. Right, we'll do one more of these slightly trickier ones with a negative in it. In exactly the same way, we've got minus 3 times n. It's minus 3n plus 4. So there's a 1, then plus 4. So it's minus 3 times n plus 4. Then we'll want minus 3 times n, but this time n is 2 plus 4. Then minus 3 times 3 plus 4. Minus 3 times 4 plus 4. Minus 3 times 5 plus 4. And we work these out. Now, this time, fortunately, the multiplication's first, so we don't even have to think about that. But we do have to be careful with this minus 3 here, because a negative 3 times a positive 1 is still a negative 3. So what we've actually got here is minus 3, then plus 4. And if you think of a number line with minus 3 on it, minus 3, minus 2, minus 1, 0, then up to 1 and 2, 3 and so on. If you're going from minus 3 plus 4, you're going to go in this direction. You're going to start here and you're going to go 4 jumps. 1, 2, 3, 4, and you're going to end up at 1. If you have problems using negative numbers, I would always suggest using a number line to make sure you get the right answer. So this one here, minus 3 times 2, that's minus 6. So you're going to start at minus 6 on your number line, then go in the positive direction 4, you'll end up at minus 2. And then this one here, minus 3 times 3 is minus 9, plus 4 is minus 5. This one, minus 3 times 4 is minus 12, plus 4 is minus 8. And this one, minus 3 times 5, it's minus 15, plus 4 gives you minus 11. So this sequence goes 1, minus 2, minus 5, minus 8, and minus 11. Okay, here's 3 more for you to have a go at. Press pause and have a go. When you want the answers, I'll take you through them. Just press play. Okay, here are the answers. For this first question here, the answers go 5, and then 2, then minus 1, minus 4, and minus 7. For this next question, you have 16, 12, 8, 4, and 0. And for this final question, you have 1, 0, minus 1, minus 2, and minus 3. Right, there's one more thing you need to be able to do, and rather than finding the first 5 terms, you need to be able to find any term in the sequence. So, can you find the 10th term, can you find the 20th term, and can you find the 100th term of the sequence 6n plus 13? Now this is not any harder, you just need to make sure you replace the n with whichever term you're after. So if I want to find the 10th term, then what I'm going to do is 6n, but 6 times 10, because I want the 10th term, plus 13. That comes out as, well, 6 times 10 is 60, plus 13, 73. If you wanted the 20th term, same idea, 6 times 20, plus 13, which comes out as 133. And you could even do the 100th term, 6 times 100 plus 13 equals 613. So rather than finding the first 5 terms, you also need to be able to find any term in the sequence. Okay, here's 3 for you to have a go at. Again, press pause, write down your answers. When you press play, I'll take you through them. Okay, here are your answers to the questions. We have the 10th term, the 15th term, and the 19th term is what we've been asked for each of these sequences. So 2n plus 2, when we do the 10th term, we substitute 10 in, and for that you get 22. When you substitute in 15, you get 32, and when you substitute in 19, you get 40. For the 5n plus 1 sequence, when you substitute in 10, you get 51. When you substitute in 15, you get 76. And when you substitute in 19, you get 96. And for the final one, 100 minus 3n, being careful with this negative sign again, when you substitute in 10, you get 70. When you substitute in 15, you get 55. And when you substitute in 19, you get 43.